Hi everyone, I hope everyone is doing good. I'm a data engineer and I would like to share my knowledge on the industry wide used data processing framework which is Spark. And everyone, or the if someone is new into this Spark and they can understand it as a lightning fast cluster computing technology which does the data processing in an within a high speed. So let's go into the details. So when we do one data and on top of the data we are going to perform some analytics that is going to bring some useful insights out of the huge raw data. So let's go see what is a Spark. And so Spark is an open source framework and it's a distributed processing system used for the big data workloads. So you can think it as an terabytes of data, GBs of data, or petabytes of data. Even you can work with the smaller sets of data also with the Spark. So it performs the in-memory caching and optimized query execution for faster queries against any data. So before we used to have the Hadoop framework which is MapReduce, and that was didn't give the much performance when some user wants to do some analysis in a quick way. So now it's possible to do the faster analysis using the Spark. So let's go into the features. The first one is lightning fast processing speed, and another is ease of use, real-time stream processing, and it's flexible. And the one other main important thing is it's fault tolerant. So let's go to the each of lightning fast processing speed. So I made it as an very clean with some icons. If you see for the first point, any organization wants to process their massive data with the high speed. Now, Spark is providing the best processing power for any of the organizations which have their large data sets, and that has to be processed within an less time. So Spark provides an 100x faster in memory and 10x faster on disk in Hadoop clusters. And the main core part of the Spark is RDDs, which help for the data store in the memory, and it processes everything in the memory itself, and it never spills into the disk. And if there is an less memory that is available in the clusters, then it's going to be spill into disk, and it's not in all the cases. So let's go to the ease of use. So Spark allows the multiple white developers into different streams who are working on Java, Scala, Python, and R. So the APIs is available in the different programming languages, and it helps in the real-time stream processing. So using the stream processing which is given by Spark, you can design any of the streaming applications. So Spark supports both streaming and batch processing. If let's see what is batch processing. To process the history data which is already available in the Hadoop clusters. Let's suppose the data is ingested into your Hadoop cluster some 10 days back. So you are going to process it. That is called a batch processing, because the data is already available for you and you are going to process it. Streaming means the real-time data. Like if for suppose you can take an cricket. So when the data comes on live, so someone is going to process the data using the Spark streaming application. Flexibility. Spark can run independently in a cluster mode without the help of any of the other process. And it can also run on Hadoop, Yarn, Apache Mesos, Kubernetes, and even in the cloud like AWS, the famous, and Azure, Google. And so let's go to the second one. So Spark can run on the Yarn cluster manager and read any existing Hadoop data that is available. It can read data from S3 and HDFS. Can connect to any of the database. Like if suppose you can connect to an Oracle system and read the data and write to of the any supported systems like S3. Fault tolerance in Spark. So Apache Spark provides fault tolerance through Spark abstraction, which is RDD. So RDDs are designed in a way that if there is any failure in your node, and it makes sure that it creates the data through the DAG again, and there will be no data loss for you. So there will be absolutely zero loss of data. So let's go to the Apache Spark ecosystem. So the base part of the Spark is Spark Core API, which is like RDD level. So you can code in R, SQL, Python, Scala, and Java. So on top of that, the frameworks are Spark SQL, streaming, ML, which is machine learning part of Spark, and graphics computation. So if we go into the deep of each of the system, Spark Core, any functionality provided by the Spark are built on Spark Core. So it does it in memory processing. So when we think about the Spark, so the first thing that should be come into our mind is in memory processing. It provides a parallel and distributed processing, Spark SQL. So it came in the next later versions, which provides the flexibility to work with the structured data using a data frames. Spark streaming. So we are done with this Spark SQL, which provides the structured processing of data using data frames. Now when we go to the Spark streaming, it provides the processing of an live analytics data, live data, and to perform some analytics on top of that data. So it can connect to the different data sources, which is Kafka, Flume, Kinesis. So Kinesis is part of the AWS, and you can connect to any socket and pull the data. Spark uses a micro batching for the real-time process streaming. So it means that it's going to pull some data for an interval of time. For suppose it pulls the data for around 5 seconds, and it's going to keep it itself, and then it's going to process it. But the one thing we have to understand is Spark is not completely real time, but it's almost real time. Spark ML. So Spark even came up with the machine learning libraries to run on the highly scalable machines. It provides a high quality algorithms and high speeds. So you will be having every machine learning algorithms like linear regression, clustering, and everything. So last one is Spark graphics. We can perform the clustering, classification, travel searching, and pathfinding. We remember which some of the algorithms which are used for finding the shortest path, right? So here comes the Spark graphics for those. And I'm done for the lecture. Thank you for watching the video. I will come up with the next things in the next video. Thank you so much. Bye bye.